Hi everyone, thank you for your time to join this presentation. My name is Hantang Qin. I'm currently a faculty member in Industrial and System Engineering at University of Wisconsin in Madison. So my team has been focusing on the in-space manufacturing microelectronics for the past 7-8 years. So today's talk, I want to show you our progress and then demonstrate to you the roadmap of how to get the certified printing work for different space relevant agencies. In our case, we have been mainly working with NASA on this topic. This presentation is based on the work with collaboration from Iowa State University, Arizona State University, and the NASA two centers, Ames Research Center and Marshall Space Flight Center. So for this work, we have present these slides at the International Space Station Research Conference, and the slide is approved by NASA for that purpose. So in this short video, you are seeing is the way of how we validate the printing technology for space manufacturing. I will show you in details in the next few slides. So to get started, I want to quickly brief about the status of in-space manufacturing and why we need the space manufacturing for different purposes. So it's mainly about the need. The need is the driving force for the technology development. If we consider the space stations, all the space stations have a lot of electronics components, thousands of electronics components under harsh environment. And in this environment, a lot of device sensor actuators, they may get damaged over time. So for the space missions, it's hard for us to bring up the backup components for each and every pieces for the space missions. If anything got broken, any chips has malfunction, we have to figure out ways that we can make those customized electronic devices in space. So the best way from our perspective is to think about the ways that we can bring additive manufacturing facility along with the materials that we can achieve the manufacturing of microelectronics and semiconductors in space. So this is associated with the cost, associated with the different types of missions. If we simply work on the study of the electronics at the International Space Station, there is a payload launching cost estimated by SpaceX. But if we start to target the Moon's mission or the Mars mission, the cost of logistics to send all the materials and electronic components to those places will be increased exponentially over the years. So the idea for our work is trying to figure out how we can achieve this, manufacturing the pieces in space. There are several challenges associated with in-space manufacturing. The most dominant one is the effect of gravity on the printing technology and material handling. When we print in space, the first dominant thing is there's no gravity over there. How to achieve precise control over the manufacturing process that we can make the same high quality devices as we did on the ground will be the challenging issue. The second part will be the power and the space limitations. A lot of printers that we see at the on-ground demonstration most time comes with a large size, but we don't have such payload for space missions. So we have to develop the miniaturized version of the printer so that it can be used to support the missions. We also have to consider how to handle the waste materials, how to manufacture the device at the micro nano scale so that they can support all those different various needs come up with the space electronics. Well, the best way identified by multiple agencies is to use additive manufacturing to serve as the role for the manufacturing platform for microelectronics and semiconductors. Imagine there will be less chance that there will be a fully implemented clean room over here in space. So it's hard for us to establish clean room on the Moon, on the Mars, for example. So in this case, the additive manufacturing platform would be the best platform for those purposes. And per definition, there are so many different types of additive manufacturing process. A lot of the additive manufacturing process will be working under zero gravity. In the past 10 years, there have been multiple publications and reports to report different types of additive manufacturing processes that can be used to support the space missions. So in my team, we specifically focus on the material jetting technology with a focus of electrohydrodynamic inkjet printing. It's a long name, so we will call it EHD printing for short. We use this technology as the dominant process for us to manufacture the electronics in space. In order to be there. If we talk about manufacturing in space, we are probably projecting a 5-year, goal starting from today.